Hello coders, I welcome you all. As you know, we have been working on our project water potability prediction using machine learning. In the last video, we have performed experiment tracking without a DVC pipeline, right? Now in this video, we are going to perform experiment tracking with our created DVC pipeline. We will create a DVC pipeline from scratch with a standard machine learning project template, cookie cutter template, that also we have used earlier. Also in this video, we will discuss the difference between two very important commands of DVC, DVC repro and DVC exp run. You can skip some of the parts of this particular video if you have already created a DVC pipeline with a cookie cutter template that we have created earlier, and you can directly jump to the experiment tracking section of this video. So let's get started. Let's open command prompt, and first we have to install cookie cutter using this particular command, pip install cookie cutter. Let's press enter. You can see in my case requirement already satisfied because I have already downloaded this cookie cutter on my machine. After that, we have to download cookie cutter template for machine learning project using this particular command, cookie cutter -c v1 https://github.com/driven-data/cookie cutter -data-science. Let's press enter. As you can see, it is asking for project name. Let's give water potability -prediction. Let's press enter. Same name. For repo, water potability -prediction. Let's press enter. Author name, data thinkers. Let's press enter. Description, you can give any description. Water potability prediction using ML. Let's press enter. Let's choose 3. No license file. Let's press enter. Again, we are skipping this step. This particular step. Let's select Python 3. Let's press enter. Now done. Let's move to this particular directory, and from here we have to open VS Code using this particular command, code dot. Now you can see over here we have successfully downloaded cookie cutter template that you can see over here. So this way we can download cookie cutter template for machine learning project that you can see over here. Now let's move on. As you can see, various folders and files designed to manage our machine learning project that you can see over here, provided by cookie cutter template that you can see over here. Let's first understand this project structure. So for that, let's click on this particular file, readme.md. You can see over here, each and every information about this project structure is given in this particular file in proper format that you can see over here. Let's start with license. So this file containing licensing information for project. As you know, we have not selected any license while installing cookie cutter. Next is make file. It defines commands like make data or make train for easy execution of project tasks. Now readme file. As you know, top level readme file providing an overview of the project for developers that you can see over here. Now you can see very important directory, data directory, which contains 4 subfolders like external, interim, processed, and row that you can see over here. Now first folder, external. This folder keeps data from third-party sources, not generated by the project itself. Next, interim. This folder keeps the intermediate data that has been transformed but is not the final data for modeling. Now next folder, processed. This folder keeps the final clean data sets ready for modeling. Don't you worry, we will use these folders shortly. Next, row. Original immutable data dumps that we have to keep inside this row folder. Now next, docs. A snippets project for generating documentation related to the project. So using this particular website, we can generate documentation for our project. We will not use this in this particular project. Next folder, models. So this directory or folder for storing trained and serialized models. As you know, serialized means saved model that we have saved using pickle, right? Model.pkl. So if you notice, as you can see, as per our created project structure, we kept model.pkl outside that you can see over here. But according to this template, cookie cutter template, it's better to place it inside this model folder, this one. Now next, notebooks. As you know, we have also created Jupyter notebook for our project, for this particular project, for exploration, analysis, and experimentation that we can keep inside this particular folder, notebooks. Now next, references. So in this folder, we can keep references related to the project if we have used from different sources like research paper, if we have used, or YouTube link if you have used to create this particular project. Now next, reports. Here in this folder, we can keep generated analysis results in various formats like HTML, PDF, LaTeX, along with associated figures. Now next, very important and very common file, requirements.txt. This particular file, requirements.txt file, specifying dependencies needed to reproduce the project environment. I will show you shortly. Next, setup file. Actually, this particular script is used to make module of our project. So someone can install our created module using pip. Now next, very important folder, source, SRC. As you can see, this is our created project structure. You can see in our project structure, we have kept every Python files in the same SRC folder that you can see over here. But as per the cookie cutter template, we have to store different Python files in different folders that you can see over here. First, data folder. Here we can store files for downloading or generating data, like in our case, data collection.py. Features. So here we can keep Python files that we have created to transform raw data into features for modeling, like feature engineering.py. So now next, folder, models. So here we can keep different Python files that we have created for model training and model evaluation. Like in our case, model_building.py and model_eval.py that you can see over here. Model_building.py and model_eval.py that we can keep inside this particular folder, models folder. Don't you worry, I will show you shortly. And final folder of this source folder, visualization. Here we can keep scripts for creating visualizations like visualize.py. Now next, ini file, configuration file for running talks, tests, ensuring code quality and reproducibility. As you can see how cookie cutter has solved the problem of project structuring that you can see over here. Now let's move on. Now let's click on this terminal and let's create new terminal. Now first, let's create a virtual environment. As you know, virtual environments in Python simplify managing dependencies and Python versions for different projects without disturbing base environment that we are currently using that you can see over here. So virtual environment ensures each project has its own isolated space, preventing conflicts between packages. So this isolation also enhances reproducibility, security, and makes it easy to clean up unused environments when projects are finished. So we can simply remove this virtual environment when our projects are finished. So overall, virtual environment streamlines development and help maintain a consistent and efficient workflow without disturbing our base environment. So let's create virtual environment. So for that, we have to write this particular command, Python -m -v, and here you can give any name. Let's give my env. There are different ways to create virtual environment. Also, we can use Conda to create virtual environment. But currently I'm using Python to create virtual environment. Let's press enter. As you can see, a message from VS Code. We noticed a new environment has been created. Do you want to select it for the workspace folder? Yes, but we will select using command. Let's close this window. So first, we have to activate our created virtual environment using this particular command, vnv/scripts/ activate. Let's press enter. So if it is showing same message to you in your system, then you have to use this particular command to change the execution policy. Let's press enter. Let's clear this and again let's activate our created environment. You can see over here. Now we are in our created virtual environment, my env, that you can see over here. You can take these commands from description of this video. Now let's first check how many dependencies are installed in our current environment. For that we have to use this particular command, pip list. You can see over here. Only 2 packages are available in this particular environment, my env, that you can see over here. So now first let's remove unnecessary files from the current project structure. Let's click on src, on data. Let's remove this particular file. Also take underscore dataset.py provided by cookie cutter. But we have already created this. So let's remove this file as well. Let's click on this folder, features. Let's remove this. Also this file, because here we are going to keep our created files. That's why here we are removing these unnecessary files, which are already available in this particular template, cookie cutter template. Also from here, let's remove this. I think all done. So now let's initialize Git using git init command to maintain our code versioning. Let's press enter. Now you can see over here. Now it is showing this particular flag U for on track. And here you can see Git has created this particular file, git ignore, that you can see over here. So this particular file .git ignore is a hidden file. Helps manage which files and directories Git should ignore in your project. Means if we mention here any file or folder, these files and folders are not tracked by the Git. So we do not want to track my env. Look at here. Now let's press Ctrl S to save our file. You can see over here. Color has been changed. Now it will not track by Git. Same models. This one. Look at here. Let's press Ctrl S. You can see over here. Now it's become untrackable. Now Git will not track this particular folder, models. Also reports. This one. Let's press Ctrl S. Look at here. You can see over here. Now Git will not track this particular folder, reports. And you can see by default, data is also mentioned by cookie cutter inside this git ignore file that you can see over here. Exclude data from source control by default that you can see over here. So this way we can put different files and folders inside this git ignore file that will not track by Git. So here in this particular file, git ignore file, we can specify the files and folders that we don't want to track by Git. You can see here 2 folders with the same name, models, and here also models. So let's rename it with model. Now done. You can see here. So now you can see as per our requirement, we have cleaned our cookie cutter template. Now let's move on. So as you know, we have initialized Git. Now let's check Git status. You can see over here this many untracked files. Now let's first add all the files to staging area using git add dot. Dot means all the files. Now let's check Git status. You can see over here changes to be committed. Now you can see these all files are currently inside our staging area. Now let's perform our first commit. Added cookie cutter template. Let's press enter. Now done. Let's check Git status. You can see over here. All done. Now let's move on. Now let's create new repo on GitHub. As you can see, currently I'm using my GitHub. Let's create new repo with name water-test. You can give any. Let's write description. Water potability prediction using machine learning with DVC pipeline. So here we are selecting public, all done, and let's press this button, create repo. So now let's copy this and let's move to our project. And here we have to write this particular command, git remote add origin, and let's paste this particular link. Let's press enter. Done. Now let's push this all to GitHub. So for that we have to write git push origin master. Let's press enter. You can see we are transferring all to our GitHub. Let's check. Let's reload this page. You can see over here docs, notebooks, references, source. You can see over here. Now you can see we have successfully connected our code with GitHub, that you can see over here. Now let's move on. Let's add different Python files that we have created for our project to this particular template. As you know, this is the template that we have created for our project with these files: data collection, data pre-processing, model building, and model evaluation. Let's copy this code from this particular template that we have created to our cookie cutter template. Let's select this code. Let's copy this code. Let's move to our template. Now in src folder, let's click on this data folder and let's create new Python file with name data collection.py. And let's paste our code. Let's save our file. As you can see here, our modular code for data collection that we have created in the last video that you can see over here. Now let's check git status. You can see over here. Now let's add this particular file to staging area. Let's perform commit added data underscore collection.py. Let's press enter. Let's check git status one more time. All done. Again, let's click on this data folder and let's create new Python file with name data underscore prep.py that we have created for data pre-processing. Let's move to our previous project structure and let's select, let's copy this code. Let's move to cookie cutter and let's paste code here. Let's save our code. Again, let's clear this. Let's check git status. You can see, let's add this file to staging area and let's perform commit added data underscore prep.py. Again, let's check git status. Done. Now, currently we do not have any file for feature engineering. If you have, you can keep code in this particular folder. But now let's click on this particular folder, model. Let's create new file with name model underscore building.py. Now let's move to our previous code and this particular file, model underscore building.py. Let's select all using Control A, Control C. Let's move to cookie cutter template. Let's paste it over here. Let's save our code. Now let's check git status. You can see over here. Git add dot git commit with message added model underscore building dot py. Done. Let's check git status again. All done. Let's clear this. Now let's click on this particular folder and let's create new file with name model underscore. You can see over here for model evaluation. model underscore eval dot py. Let's rename this model eval dot py. Now let's move to our previous structure. Control A, Control C. Let's move to cookie cutter template. Let's paste code over here. You can see. Let's save this file again. Let's check git status. You can see over here. First git add, git commit, added model underscore eval dot py. Again, let's clear this out and git status. All done. Now let's create new file over here. params.yaml. Now let's move to our previous project structure. This file params.yaml. Let's select, let's copy, let's move to cookie cutter, let's paste it over here, let's save, let's check. You can see, let's add this file to staging area and let's perform commit. Added params.yaml file. Let's clear this out. Let's check git status. All done. Now let's move on. First, we have to install dependencies. As you know, here we require pandas, numpy, sklearn, and YAML as well. You can see in cookie cutter requirements.txt file is already available. Let's click on this. Let's remove this all. And we required numpy for this project, pandas for this project, scikit-learn for this project, and YAML. So for that, we have to write py-yaml. Let's save this file. And now let's install all these modules in this particular environment that just we have created, myenv, using pip install -r requirements.txt. Let's press enter. As you can see, installation has been started with numpy, then it will install pandas, then it will install scikit-learn, then it will install YAML. We have to wait. As you can see, all these packages are installed successfully in our environment, myenv, that you can see over here. Let's clear this. We can also freeze this all dependencies back to requirements.txt. So somebody can reproduce our entire project. So for that, we have to write pip freeze to requirements.txt. Let's press enter. You can see over here all the modules with particular version that we have used in this particular project. So someone can reproduce our project by installing these dependencies available inside requirements.txt that you can see over here. Now all done. Now the main section of this project, DVC pipeline. So now to execute this code, we have to connect all these files, means all these modules, data collection, data pre-processing, model building, and model evaluation into one sequence using DVC pipeline. So let's create DVC pipeline using command DVC stage add. That will create one file, dvc.yaml. So as you know, we have to run dvc.yaml to execute our pipeline. So let's create dvc.yaml using dvc stage add command. So let's add our first stage to dvc.yaml file, data collection stage. So we are going to add this particular stage to our pipeline as a first stage. So here is all done. No need to change anything. This path is okay. params.yaml file path is also okay. And this path is also okay. Data and row. Data and row. This one. So now let's add this particular stage, data collection stage, as a first stage to our dvc.yaml file. So for that, we have to write dvc stage add command. Stage name data underscore collection dependencies src data and this particular file data collection dot py. And what will be the output of this stage? Data slash row folder. And how we can execute this stage? Using Python src data underscore collection dot py. Now you can see in our previous structure, these particular files are available inside src directly. But as per our cookie cutter template, all these files are available inside src data that you can see over here, src model likewise. So that's why here we have to write like this, src data and data collection dot py. Let's press enter. You can see over here, error. You are not inside of a DVC repository. Please remember, we are going to create DVC pipeline. So for that, we have to initialize DVC first using DVC init. Now you can see we have successfully initialized DVC. Let's clear this. Let's press up arrow and this is our command. Let's press enter now. As you can see, dvc.yaml file is created. Because of this command, let's click on this. You can see we have successfully added our first stage to DVC pipeline. Let's execute this. DVC repro command. You can see we can successfully execute our first stage. Also, we can visualize this particular stage. You can see over here. Now you can see we have successfully completed our first step. Just we have added data collection stage to our DVC pipeline. Now let's move on. Now let's add our next stage to our DVC pipeline. Data pre-processing stage, this stage. So again, we have to write this particular command. DVC stage add stage name pre-processing dependencies src data underscore prep.py means this file itself. Another dependency data row, because you can see these two files are created in the row folder after first stage, data collection stage. We have to add as dependency for this particular stage, for our second stage, data pre-processing, and output of this particular stage inside data processed in this. And how to execute this particular stage? Python src data underscore prep.py. Let's press enter. You can see we have successfully created our second stage of our pipeline. Again, let's check dvc.yaml file. You can see over here. Let's clear this. Again, let's reproduce our pipeline. All done. Let's check this particular folder. As you can see, after this particular stage, our second stage, these two files are created. Test underscore processed.csv and train underscore processed.csv. Let's clear this. Now let's add our third stage, model building, to our DVC pipeline. Here inside dvc.yaml file. Again, we have to write this particular command. DVC stage add name of this stage, model building, dependency, same file, src data. Now it is not inside data. You can see src model slash model underscore building dot py, dependency data underscore processed, generated by our previous stage. Output of this particular stage, models here. Here we are going to store model.pkl. And how to execute this particular script? Using Python src model slash model underscore building dot py. Let's press enter. You can see we have successfully added our third stage to our DVC pipeline that you can see over here. Let's clear this. Let's execute our pipeline. As you can see, this particular error, because as you know, we have to add the parameters also. Let's copy this and after dependency, let's paste it over here. Let's save. Again, in model building, let's copy this. Let's move to cookie cutter template. In model building, let's paste. Let's save our file and let's re-execute our pipeline. Again, same error. So please don't forget to give models/model.pkl in this particular file. We have to give this path. Now let's save this. Let's check this file. Here is okay. I think done. Let's clear this. Again, let's re-execute our pipeline. Now done. Now you can see we have successfully saved our model in this particular folder, models, with name model.pkl, that you can see over here. Now all done for this particular stage, model building stage. Hope all of you are clear with this. Now let's move on. Now it's time to add our final stage to our machine learning pipeline, means in our DVC pipeline, this particular stage, model evaluation stage. Let's check path first. Here we have to give models/model.pkl, and we are going to store JSON file inside reports folder, in this folder. So let's save this. Now let's add this particular stage to our DVC pipeline, our final stage, model evaluation. Again, we have to write DVC stage add, name of this stage, model evaluation, dependency, same file, src model underscore eval.py, another dependency, models/model.pkl, and matrix in reports slash matrix.json file. And how to execute this script? Using Python src model underscore eval.py. Now let's press enter. Now done. Let's clear this and let's execute our pipeline using DVC repro command. As you can see over here, this file is created matrix.json inside reports folder. All done. Let's clear this. Let's visualize our pipeline. You can see over here, data collection module, data pre-processing module, model building module, and model evaluation module. Now you can see now our created DVC pipeline with cookie cutter template is working properly, right? That you can see over here. So now let's start experiment tracking. So in the first step, we need to install one library, DVC live, using following command. Let's first clear this and let's install DVC live. You can see in my case, requirements are already satisfied because I have already installed DVC live on my system. Let's clear this. So here we are going to perform experiment tracking, and we are going to track metrics such as accuracy, precision, recall, and F1 score, as well as the test size and N estimators that we have mentioned in params.yaml file. You can see over here. To do this, we need to modify the code of model evaluation.py, this one, model underscore eval.py, that just we have created. So now let's first import from DVC live. We have to import live, and also let's import YAML. To track metrics, we have to write code like this. Let's move inside this particular function, evaluation underscore model, and we have to call these particular parameters that we have defined inside params.yaml to this particular file. So for that, we have to use yaml.save underscore load, and let's open params.yaml in read mode, and it's also by default in read mode, and let's assign it to one variable params. is equal to this statement. So here we are loading this particular file params.yaml because we are going to track these parameters as well. So let's call parameters over here. So here params, and let's call this first data underscore collection. And inside this particular module, we are going to track test underscore size. Let's copy and paste it over here. And let's assign it to one variable. Test size is equal to this statement. Also, now we have to call this particular parameter n underscore estimators of this particular module. Model building module. Same we have to call like this. So let me copy this statement. Let me paste it over here. And in place of this data collection, now we have to use this particular module. Model underscore building. And this parameter, let me copy n underscore estimators and let's paste it over here. And let's assign it to n underscore estimators. Let's save our file. Now let's log metrics first. Accuracy, precision, recall, and F1 score. And here we have to write with live, and we have to set save underscore DVC underscore exp to true as live. And we have to track metrics using log underscore metric that we have already discussed in our last video. Experiment tracking without pipeline, right? So here accuracy and this one. Now also live dot log underscore metric precision and pre, this one. Same we have to log another metric recall. Same for F1 score as well. Live dot log underscore metric and F1 score, this one. Now also we have to log parameters, these parameters, test underscore size and n underscore estimators. So for that, again we have to use live dot, this time log underscore param, test underscore size, comma, test underscore size, this one. Now let's log n underscore estimators. So again live dot log underscore param n underscore estimators, comma, n underscore estimators. Let's save this file. So you can see this way we can perform experiment tracking with DVC that you can see over here, with DVC pipeline that you can see over here. Now let's execute our pipeline using DVC repro command. You can see one exception. An error occurred. Error evaluating model. Safe underscore load takes one positional argument, but two were given. Let's check. So here we have to open this file. Let's save this file. Let's clear this and let's re-execute our pipeline. Now done. Let's click on DVC. You can see that there is no experiment results available and there is no any directory with temp because experiment tracking has not been started. Please remember, we have been using DVC repro to execute our pipeline. But if we want to perform experiment tracking, we have to use DVC exp run command. I am repeating, we have been using DVC repro to execute our pipeline. But if we want to perform experiment tracking, we have to use DVC exp run command. Let me show you this. Let's clear this. And now let's perform experiment tracking. To do that, we have to use DVC exp run command. You can see now this temp file has been created for experiment tracking that you can see over here. So please remember, as I said, we are using DVC repro to execute our pipeline. But if we want to perform experiment tracking, we have to use this particular command, DVC exp run command. Please remember, if we are using this particular command for experiment tracking, DVC exp run, DVC will handle everything by itself. So now let's click on this particular extension, the DVC extension that we have installed in the last video. And let's click on this particular button, show experiments. You can see over here. This is our first experiment that just we have performed. You can see here. With test size is equal to 0.20 and n estimators is set to 100. That you can see over here. You can see this particular experiment that just we have performed. Test size 0.20 and n estimators is set to 100. And you can see for this particular experiment, accuracy, F1 score, precision, and recall. Now let's perform one more experiment and let's set n estimators to 500 and test size to 0.30. Let's save this file. Let's clear this and let's run our experiment using DVC exp run command. Now done. Now let's check this experiment. You can see here our second experiment. Test size is set to 0.30 that you can see over here in params.yaml and n estimators is set to 500 that you can see over here as well in params.yaml. So this is our second experiment that just we have performed. Now let's perform one more experiment. Let's click on params.yaml and let's set n estimators to 1000 and test size to 0.20. Let's save this file. Let's click on this. Let's clear this and let's run our experiment. You can see over here. This is our third experiment. You can see over here. Test size is set to 0.20 that you can see over here in params.yaml and n estimators is set to 1000 that you can see over here as well. So this is our third experiment. So this way we can conduct as many experiments as we want. Let's clear this. So now assume that we have conducted many experiments and we want to compare the results between two experiments. So for that we have to use following command dvc exp diff and I want to compare this particular experiment. Let's copy the name. Let's paste it over here. And this particular experiment, let's copy and paste it over here. As you know, these names have been generated by DVC, right? Let's press enter. You can see over here. First experiment, this one, and our third experiment, this one, and change that you can see over here. So this way we can compare two experiments. So let's clear this and let's move on. So please remember here we can queue multiple experiments and we can run multiple experiments at the same time like we have been doing in hyperparameter tuning using grid search CV. Let me show you this. To do this, we have to use following command dvc exp run and this particular parameter queue to queue multiple experiments and as flag. And here we can write parameters. So our first parameter is available inside data underscore correction module dot parameter name test size is equal to we can provide number of values for experiment like 0.20, 0.30, 0.25, any that you can see over here. Data underscore collection and this particular parameter. So here we are trying different values for test underscore size. Here, three values that you can see over here, 0.20, 0.30 and 0.25. Same, let's do it for model underscore building dot n underscore estimators. And let's try different values for n estimators as well, 100, 250 and 300. So here we are performing this many experiments. So as you can see in this particular command, we are providing three values for test underscore size parameter and three values for n underscore estimators parameter. So total 3 cross 3 is equal to 9 experiments will be executed. Let's press enter to execute this particular command that will perform 9 experiments with three values of test underscore size and three values for n underscore estimators. Let's press enter. You can see here queuing experiment. So when you will run this command, it will queue each and every experiment and you will see that a unique name is assigned to each experiment that you can see over here. You can see unique name is assigned to each and every experiment. Now queuing is done for our 9 experiments that you can see over here, each with unique names. So now if you want to run all these 9 experiments, we have to use following command. Before that, let's clear this and let's use DVC exp run hyphen run hyphen all. So this command will run all our 9 experiments that just we have queued. Let's press enter. You can see following logs for all queued experiments that you can see over here. You can see currently these experiments are running. We have to wait. Let's clear this and let's try to run it one more time. You can see all done. And you can see here our 9 experiments that just we have performed that you can see over here. You can see test size with 0.20, 0.25 and 0.30 that we have used here, that you can see over here, 0.20, 0.30 and 0.25 with n estimators 100, 300 and 250 that you can see over here. Total 9 combination, 3 cross 3. 3 values for test underscore size and 3 values for n underscore estimators that you can see over here. Total 9 experiments. Hope all of you are clear with this. How we can queue multiple experiments and how we can run multiple experiments at the same time that you can see over here. So this is the advantage of using DVC pipeline that you can see over here. This way we can run multiple experiments at the same time that you can see over here. Let's clear this and let's move on. So as you can see, we have performed these many experiments. Now suppose we want to remove one particular experiment that we can do using following command: DVC exp remove and name of the experiment. Let me copy this name and let me paste it over here. Let's press enter. Please look at here. You can see that particular experiment is removed. Let's remove this as well. DVC exp remove and name of the experiment. Let's press enter. You can see over here that particular experiment is also removed. So this way we can remove particular experiment. Now let's move on. Let's clear this. So now here the question is why we are performing these experiments? Because we want to find the best model that we can use in the production, right? So assume that after these many experiments, we found one best model. Assume that this is our best model that we have found after these many experiments. So now we have finalized this as the best model, this one. So we have to reproduce this particular experiment. You can see the current value of test size and n estimators. But here we want these particular values as per our best experiment. So we have to reproduce our best experiment that just we have selected as the best. So we can do this with just one command: DVC exp apply, and let me copy the name of our best experiment and let's paste it over here. Let's click over here. Let's open params.yaml. Please look at here. Let's execute this particular command. I'm going to press enter. You can see over here. As you can see, this particular experiment have been applied to our current workspace that you can see over here, that we have selected as the best experiment. You can see here entire code base and everything else have been updated as per our best experiment. And you can see that matrix.json has been updated and also params.yaml has been updated as per the values of the n estimators and test size, means as per our best experiment that just we have selected. Also you can see here our workspace has been updated as per our selected best experiment. You can see test size 0.20 and estimators 1000 that you can see over here. Let's clear this. Now we have selected our best experiment. Now let's commit this particular experiment. Let's check git status. You can see these files are modified and untracked files. Let's clear this. Let's perform git add dot git commit -m based experiment test underscore size is equal to 0.20 and n underscore estimators is equal to 1000. Let's press enter. All done. I hope all of you are clear with how to perform experiment tracking with DVC pipeline. So in the next video, we will perform experiment tracking with MLflow. Hope all of you are clear with this. Hope you like this video. Please don't forget to subscribe this channel. If you like this video, smash that like button. Thank you very much for watching this video. Take care. Bye-bye. See you in the next video.